How's everyone who's watching this? This is my 35th video on the channel. Today we're going to be finishing chapter 3 of Intensive Science and Visual Philosophy by Manuel DeLanda, titled The Actualisation of the Virtual in Time. In the last episode, we began examining the role of time in Deleuze's philosophy, seeing how metric time or Chronos forms through the unfolding of a nested set of oscillators. In this episode, we'll take what we looked at last time and expand on it, similar to what we did in episode 4 with space. As a bit of a disclaimer, this is a very dense chapter, so if you all have any questions about anything I say, please let me know so I can try my best to clarify. Without further ado, DeLanda begins this half of the chapter by talking about rates of change. In his words,
although a rate of change does not need to involve time, time does enter into the formulation of many important rates.
These rates of change form assemblages together, syncing up. If you haven't seen the last couple of videos, assemblages are basically groups of heterogeneous entities that connect to each other through affects, capacities for affecting and being affected by others. The example of an assemblage that DeLanda offers at this point is on the graphic patterns many animals sport on their skin, like spots on leopards or stripes on zebras. These are caused through a myriad of heterogeneous rates matching up, like that of how fast chemicals interact with each other relative to that of diffusion of products through an embryo. This is all to set up a discussion about the work of a physicist Howard Petit, who differentiates between rate-dependent and rate-independent phenomena in the development of organisms. Here, it's worth to expand the metaphor we just looked at, which we can do with this diagram. As you all can see, genes are rate-independent. What this means is that it doesn't matter how fast or how slow they're decoded. They simply are, a kind of static information. However, when enzymes come into play, everything changes. Now, the information that we find in genes is being realized through the coupled rates of reaction and diffusion just discussed. Enzymes are catalysts, chemical elements that can accelerate or decelerate reactions. With this in mind, we can picture embryogenesis as being almost like a computer program. Information gets inputted before being processed through diverse yet connected rates of change. However, there is a problem with this way of thinking.
There are different kinds of computer programs presupposing different forms of time, some using sequential or serial time, others departing sharply from these linear forms of temporality.
This is where the parallel temporal structures we talked about last time come in. If you haven't seen that video or don't remember, assemblages involving temporal elements tend to become synchronized. For example, our circadian rhythms synchronize with the day and night cycle. Returning back to embryogenesis as a process of individuation, this allows us to think about development and evolution in a totally new light. Basically, the conventional view of embryonic development pictures eggs as an assembly line, where each process occurs one after the other in a linear fashion. When it comes to innovation or evolution, it's thus that any new structure comes at the end of this process. However, when we apply the lens of parallel temporality, we can see that there's actually a myriad of bundles of things happening all at once. Change occurs when these bundles, for whatever reason, fall out of sync. Just like how an alternation in the rates of change that give leopards their spots will lead to a totally different pattern. Here, DeLanda introduces neoteny as an exemplar of these processes. It involves the rate of change between sexual maturation, the development of a body, becoming decoupled, the former being accelerated in relation to the latter. This notion of decoupling rates is useful because it shows us how evolution involves the loss of features, not just the addition of new ones. For Deleuze, processes like neoteny are important for understanding individuation, because it shows that change isn't just a drive towards more and more complexity, but rather is much more nuanced. DeLanda now moves on to the study of ecosystems. Population density, he says, is an example of an intensive property. Just like temperature or pressure, you can't change it by splitting it. Like all intensities, it also has thresholds where it bifurcates or radically changes. For example, a low enough density, called the nucleation threshold, leads to a population going extinct. The reason for outlining this is that it offers us a window into how ecosystems operate on different timescales. We can see this in the different factors that influence population density and their reaction to bifurcations. For example, there's the role of birth and death rates. In DeLanda's words,
this factor displays a relatively short time scale of return to equilibrium.
In other words, when a shock is applied to the rates, they tend to bounce back rather quickly. Next, we get assemblages like the food chain, with population densities of herbivores, plants, and carnivores all forming parallel structures. In these cases, any shock can lead to a much longer return to equilibrium. When one population density undergoes bifurcation, a ripple effect is released, cascades of changes occurring as a result. Turning back to embryogenesis, seemingly DeLanda's favorite thing to talk about, he introduces what Deleuze calls speeds of becoming and capacities to become. These are roughly equivalent to singularities and affects respectively. An environment where individuation is taking place, like inside the developing egg, is defined by its speeds, parallel processes linking up through relative rates of change, some fast, others slow. Likewise, parallel processes only exist in the first place through capacities to become, their affects. At this point, our author underlines, we have to reintroduce space into the equation. So far, we've only talked about space and time individually, ignoring the fact that almost all phenomena are complex and spatiotemporal in nature. As DeLanda says,
the question of the emergence of extensive properties should be treated as a single process in which a continuous virtual spacetime progressively differentiates itself.
To do this, we have to go all the way back to the quasi-cause and ideal events from episode 4 of the series. The form essentially works through extending every singularity, every virtual point around which processes are organized, into an infinite set of the latter, or the possible ways that the singularity can be actualized. As you saw in that video, Deleuze draws heavily from abstract communication theory, where the quasi-cause affects multiplicities by changing the probability of events through linking series of them together. It's important to note that these probabilities, existing in the virtual rather than the actual, are not tied to any exact values, 10%, 50%, what have you. As seen in this diagram, they are instead defined by their order in relation to other events, from first to second to third, and so on and so on. To quote DeLanda,
the first task of the quasi-causal operator is a process involving the continuous creation of communications between the series emanating from every singularity.
As series are linked together by the quasi-cause, they come to form something of a continuum. It's this that he says accounts for the spatial side of a virtual. However, there's also a temporal component, what Deleuze calls Aiôn. In the philosopher's words,
there is always a space which condenses and precipitates singularities, just as there is always a time which progressively completes the events through fragments of future and past events.
Essentially, as we discussed in the first few episodes of the series, virtual space unfolds in a specific way, through a cascade of symmetry-breaking transformations. However, the time involved in this process is very different from that of actual events. In the actual, there's a sequence moving from one thing to the next. Like in our hydrodynamic example from episode 1, it goes conduction, convection, then turbulence. Additionally, at every bifurcation, every symmetry-breaking transformation, only one possible alternative is actualized. This is in stark contrast to how time works in the virtual. There, all bifurcations coexist at the same time, instead of following each other the one after the other. Moreover, to quote directly from DeLanda, each broken symmetry produces all the alternatives simultaneously. To account for this absolute coexistence, we need to figure out how we can possibly conceive of virtual time. It can't be thought of as based in the present, since, as we saw in the last episode, the present assumes a specific stretch of time on a certain scale, but it also can't be thought of as forming some kind of timeless eternal dimension, as that would be no better than essentialism. Instead, we have to picture the virtual as being made up of what Deleuze terms pure becomings. These are bifurcations without any sequentiality or directionality. This may sound quite confusing at first, but hopefully this diagram can clear it up a bit. Take 0 degrees as an example of a threshold where becoming takes place. In the actual, water either becomes ice or ice becomes water. Only one of the two can occur. This is what is represented on the top section. However, this isn't at all how it works in the virtual. Here, the threshold is the event itself, one that is never actualized. Both directions of becoming occur in parallel. It's a melting freezing event which never actually occurs, as DeLanda says. Although our author doesn't cite this quote, what helped me wrap my mind around the concept of a pure becoming comes from Deleuze's logic of sense, where discussing Alice in Wonderland, he says,
when I say Alice becomes larger, I mean that she becomes larger than she was. By the same token, however, she becomes smaller than she is now.
She's small in the past and larger in the future. Both directions of a pure becoming occur at once. This is the heart of Aiôn, which always sidesteps the endless present of actual time, what we discussed in the last episode as Chronos. It is always simultaneously already past and eternally yet to come, as DeLanda writes. At this point, he turns back to multiplicities and the quasi-cause. As we looked at 2 episodes ago, multiplicities are themselves impassive. They can't impact other things. Aiôn complements this by his avoidance of a present. However, there's also the quasi-cause, which, to bring up a diagram from that episode, has the pure capacity to affect. The first job of this quasi-cause is to weave multiplicities together in order to produce something of a heterogeneous continuum. This, upon first glance, leads to something of a paradox. If multiplicities only exist in the past and the future, how can the quasi-cause ever affect it? Deleuze's answer is the instant, something that unfolds itself in both Aiôn's directions without having any duration itself, simply acting as the divider between the 2 different sides. As DeLanda notes, this description of virtual time is much less precise than that of virtual space, although for good reason.
The latter has the advantage of over a century of mathematical work on the nature of non-metric spaces, whereas similar formal treatments of time do not really exist.
However, as he continues on to say, even the spatial side of Deleuze's ontology might seem too complicated and speculative to be useful. Why then develop an immanent theory in the first place? Well, the answer comes down to just how problematic essences are. It's undoubtedly simpler to imagine a transcendent world of Platonic forms, but that familiarity comes at a price. It's a mistake to write off something simply because it's more complicated, he says. Here, DeLanda wants to shift gears to discuss another aspect of a quasi-cause, the way in which it immanently produces multiplicities themselves. Essentially, they are formed from a quasi-cause extracting singularities from the actual. Deleuze describes this process as one of slices or sections. In geometry, this usually refers to a way in which shapes can have their dimensions decreased, as seen in this diagram. A slice of a 3D cube is a 2D square. This can be extended in the domain of dynamical systems theory, where slices of a state space are used to find attractors. However, DeLanda is very careful to underline that Deleuze's understanding of slices has no true mathematical equivalent. To explain, he returns back to the hydrodynamic flow patterns of conduction, convection, and turbulence.
Let's imagine a concrete physical system in a state of convention, that is, actualizing one of the available flow patterns, a periodic attractor.
Here, the periodic attractor represents an actual system's virtual component. However, this virtual component, a singularity, only exists as the result of actual causality, like relationships between temperature and density. However, Deleuze's hypothesis is that from the system, the virtual quasi-causal aspects of it can be divined through slicing through. More than simply lowering its dimensions, a Deleuzean slice, above all, removes all actuality. Summarizing what we went over in episode 1, DeLanda says that multiplicities first entered Deleuze's work through the differential geometer Bernard Riemann, who saw them as n-dimensional things that could be studied without placing them in an n+1 embedding space. Additionally, as we saw in that episode, the dimensions that make up a Deleuzean multiplicity correspond to degrees of freedom, the relevant ways in which it can be changed. As such, every intensive process that a multiplicity can be extracted from leads to a defined finite number of dimensions, a number that differs from multiplicity to multiplicity. This poses something of a problem for what we talked about a couple of episodes back as the plane of consistency, the plane where multiplicities exist together, connected by their differences. This problem, though, only exists if we conceive of it as a two-dimensional thing, instead as Deleuze and Guattari say in 1,000 Plateaus,
far from reducing the multiplicity's number of dimensions to 2, the plane of consistency cuts across them all, intersects them in order to bring into coexistence any number of multiplicities.
Where the quasi-cause comes in is to perform this slicing operation, cutting across every multiplicity in the process. In complete contrast to a transcendent n+1 embedding space, the quasi-cause, also called a line of flight, only has n-1 dimensions. To explain this, DeLanda moves to summarize the quasi-cause's 2 tasks, which he calls pre-actualization and counter-actualization. The first refers to their role as giving multiplicities a semblance of actuality by creating relationships between the series that emanate out of them. This acts as the first bifurcation that eventually leads to a cascade of symmetry-breaking transformations and thus differentiation or actualization. The second, on the other hand, involves extracting virtual elements from the intensive. These two processes seemingly work in two totally different directions. However, DeLanda stresses, they actually complement each other. The second takes so-called flattened multiplicities from intensive processes, whilst the first unfolds them into their respective number of dimensions. As seen in this diagram, Aiôn is manifested in two different ways here. First, counter-actualization occurs instantaneously by slicing across actual events. Secondly, pre-actualization takes the flattened multiplicities from the instant and folds them endlessly into the past and the future. Deleuze describes the whole process in Logic of Sense by saying that it occurs
in a manner like a pod releasing its spores.
Both operations, in DeLanda's eyes at least, are necessary for understanding just how multiplicities act the way they do. In the chapter, he argues that pre-actualization accounts for both their autonomy from the intensive and for their morphogenetic power. In other words, pre-actualization links multiplicities together and explains why singularities attract in the first place. This is the reason Deleuze sometimes calls the quasi-cause the dark precursor, especially in difference and repetition. Now, with this, we conclude the second half of Chapter 3 from Manuel DeLanda's book Intensive Science and Virtual Philosophy. I truly hope you enjoyed or learned something, and if you feel I got anything wrong, or wasn't as clear as I could have been, please do feel free to let me know in the comments so I can do better. Next time, we'll start Chapter 4, titled Virtuality and the Laws of Physics, and begin our exploration into the epistemological side of Deleuze's ontology. Until then, bye!